we are starting to work with our algebraic expressions. So when it's an algebraic expression, what that means is it's a fraction. And there's letters in your fractions, they're not just numbers. So first thing we have to do with our algebraic expressions is talk about undefined fractions. Who remembers when a fraction is undefined? No? Yeah. So a fraction is undefined when the denominator is 0. Because we can't have that. Because if you think back to, let's think back to elementary school for a second. The whole thing we're doing with division is you're taking a number and you're dividing it into groups. So I can take 4 things and I can divide it into 2 groups. Everything works. However, I cannot take 4 things and divide it into 0 groups. That just doesn't happen. You cannot divide by 0. So that's your denominator of your fraction. We can't have that. So what happens with our algebraic fractions is we have to figure out, well, what number would x have to be in order for the undefined fraction to happen. So the way we do that is you take your denominator and your denominator only, and you set it equal to 0. And then all you have to do is solve for x. So in this case, I would subtract 5 over, and I would get x equals -5. So what you have to think to yourself is when x equals -5, the fraction is undefined. That means it can't happen. So when you solve for these, that's what you should be thinking in your head. Okay, -5, not going to work for that one. Over here, for example 2, again, I'm looking for when it's undefined, so I'm going to set my denominator equal to 0. This one's actually a quadratic, so we got to do a little factoring here. What kind of factoring is this going to be? Dots, very good. So I set up my 2 sets of parentheses, and it's still equal to a 0. So this would factor into x minus 3 and x plus 3. So we set them both equal to 0. X minus 3 equals 0. X plus 3 equals 0. So we actually have 2 answers this time. So if x were to equal either 3 or -3 this time, our fraction would be undefined. So there's 2 of them. And then the third one, even if it's just one letter there, set it equal to 0. A cannot be 0. Because if a is 0, our fraction is undefined. So as we go through with our fractions, you kind of have to keep that in mind. It's one of those unwritten things. You always have to keep track of what makes a fraction undefined, because those aren't going to be able to be our answers. So always with our fractions, we have to simplify them every single time. It's an unwritten rule. We always need to simplify. If you have monomial terms, which would be this example right here, meaning you have one term over one term, simplifying means you just combine your variables using your exponent rules and you reduce your numbers out in front. So -12 and 36. What number can go into both of those? 12. So -12 divided by 12 is -1. 36 divided by 12 gives me a 3. We did one of those on our problem of the day today, our warm-up. And now we just follow our exponents rule. So I have x to the first divided by x to the first. So those cancel. I don't have any more x's. And then y to the 8th divided by y to the 10th. So y to the -2. And then I have a z in the denominator. I don't have one in the numerator. So that's not going to change. That's going to stay as a z in the denominator. I do, however, need to move my y because I have negative exponent and I can't have that. So we still have our -1 in our numerator, and that's the only thing we have in our numerator. And then we have 3y squared z in our denominator. And that's our fraction reduced. So if you have anything more than a monomial, you got a binomial or a trinomial, like our next example, you need to factor first. So if I look here, I have a GCF of y. Actually, more than y. What would my GCF be there? Y squared. So I'm going to take out a y squared. I would be left with y minus 3 in my numerator. Factor our denominator, we would get y minus 3 times y plus 3. And so now we can cancel something from the top and something from the bottom. I can cancel y minus 3 with y minus 3. And then I can't cancel anything else because this y here is attached to the plus 3. So it's either all or nothing. I can't separate or reduce my y squared with that y because that y has the 3 attached to it. So our final answer here would be our y squared over y plus 3. That's our fraction reduced. And then with our fractions, we do have some special cases. You have to keep in mind that with subtraction, your order actually is important. So like if I subtract 9 minus 5, I get a 4. If I subtract 5 minus 9, I get a negative 4, which is different than 4. But what does that reduce to? Negative 1. So the same rule applies when we're using letters. If I have x minus y over y minus x, I can reduce those, but it reduces to a negative 1. And that only happens with subtraction. With addition, it would just be 1. Order doesn't matter because of our commutative property. But with subtraction, it does matter. So we're going to simplify some of these down here. So looking at our first example, we have to do some factoring up top. We have a GCF factor there. What would our GCF be? 3. So then in our parentheses, we would be left with b minus a. And then in the bottom here, we just want to write out a minus b times a minus b. Since it was squared, that means it's there twice. So this is going to be our negative 1 rule. I can cancel b minus a with one of the a minus b's. But I just have to remember that that turns into a negative 1. Normally when we cancel stuff out, it turns into a 1. These ones turn into a negative 1. So then I have 3 times negative 1 in my numerator, so that's negative 3. And our denominator stays as a minus b. Let's try the next one. We'll factor the top. We have a dots factor up top. So that gives us x minus 5 times x plus 5. In the bottom we have a trinomial, so I'm going to set up my 2 sets of parentheses. I know to get x squared I need x and x, so remember those need to go in the second term since x squared is last. One's plus, one's minus. And then what multiplies to give us 5? 5 and 1. We don't really have much choices there. Since this one is backwards and it's a little tougher for you to see sometimes, you got to make sure you're checking in your head. Little smile here would give us a 1x. Big smile would give us a negative 5x. So 1 minus 5, we do get our negative 4. So we did put them in the right spots. So now I can cancel x plus 5 with x plus 5. It's not negative 1 because it's adding this time, so it's all good there. That means in our numerator we're left with x minus 5. And our denominator we're left with 1 minus x. So the last thing we're going to be doing today is dealing with our multiplication and division of fractions. You've done this a lot with just number fractions. Multiplication means you multiply the top, multiply the bottom. There's your answer. You reduce at the end. Division. There was a little acronym you guys always learned. It was keep, change, flip. Does that sound familiar? Same rules apply even if there's letters. Whenever you have division, you're going to do keep, change, flip. And that's what that reminds you right there. Keep, change, flip. So if fractions are monomials, reduce the fractions by cross-canceling and using your rules of exponents. So this first one here, we have all monomials. They're all single terms there. So what our cross-cancel means is, for example, I have a 6 here. I can reduce that with the 4. I can do 6 divided by 2 gives me a 3. 4 divided by 2 gives me a 2. Can I cancel anything else out in this first fraction? Y's, 3 and 2, so this would give me y to the first, and x's. But you know what, let's do this a different way. Let's do this a different way. I'm going to put my 3 and my 2 up here. So as we said, our y's, this y squared makes this y to the third turn into y to the first. And with my x squared and my x to the fifth is my bigger exponent. So my x stays in the denominator, and that would become x to the third. Or the other way you could think of it is if I left it up here, it would have been x to the negative third. So I would have had to move it down here. It would have become x to the positive third. Now there's some more stuff that we can reduce. This 2 can go into 10 5 times. And now it's not in the same fraction, and that's okay. Anything from the top can reduce with anything from the bottom. So this x can make this x to the 5th go down by 1 to x to the 4th. This y squared makes this y to the 7th become y to the 5th. And I'm just going to bring down that 9 so I don't lose it. So let's rewrite what we have here so far. So we have 3y over x cubed in our first fraction. I still have my 3 and my y and my x cubed. Second fraction, I have a 5 over 9 x to the 4th, y to the 5th. So we can still reduce some more. 3 goes into 9 3 times. And then this y to the first makes this y to the 5th become y to the 4th. And I'm just going to bring down that x to the 4th so we don't lose it. So in our numerator here, you see how everything there canceled? Since it all canceled, it's still left with a 1. There's still a placeholder there of 1. Not everything's completely gone. So when we go to multiply now, 1 times 5 gives us a 5. And then we have x to the 3rd times 3x to the 4th, y to the 4th. So that gives us 3x to the 7th, y to the 4th. And that would be our final answer. There's nothing left to cancel. Can't reduce my 5 and my 3. I have my variables all in one spot. So then we're good. Now, if you have examples like the next two where you have binomials and trinomials, you've got to factor first, and then you can start canceling stuff. Now, this one is also division, so I need to do keep, change, flip. So I'm going to keep my first fraction. Exactly the way it was, so I just rewrite that first one. I'm going to change my division to a multiplication. and I flip the second fraction. So there's our keep, change, flip. So now we got to go through each part one at a time and factor. So 9x squared minus 1, that's the one I'm looking at right now. That is a dots factor. So I set up my two sets of parentheses. What multiplies to give us 9x squared? 3x and 3x. Then 1's plus, 1's minus, and what multiplies to give us 1? 1. 1 times 1. So now I'm going to look at my denominator and factor that one. So we start with a 3x squared. So that means I'm going to have a 3x and an x to start with. What will our signs be? Both positive. Very good. Now we got to see what multiplies to give us 2. Not many choices. 2 and 1. Now these ones, because of that 3x, again, in your head, you want to be doing your little check. Okay, this would give me a 1x. That would give me a 6x. So 1x plus 6x would give us our 7x, which was our middle term here. 7x. So now over to the next fraction. More factoring. We have another trinomial in our numerator. So we have x and x gives us our x squared. What would multiply to give us 14? 7 and 2. Our signs will be different. We want the 7 to be negative, so we get our negative 5 in the middle. And then that last part of that fraction, is that factorable? There's a GCF. What number? 5. So 5 and then 1 minus 3x. So once you've done your factoring, you get to do the fun part, I think, which is crossing out all this stuff. So 3x plus 1, 1 from the top with 1 from the bottom. 3x plus 1, 3x plus 1, they cancel. I have an x plus 2 down here, and I have an x plus 2 up top, so those two cancel. Again, it doesn't matter which fraction, just 1 from the top, 1 from the bottom. And then there's one more thing that can cancel, but it's our special rule. 1 minus 3x will cancel with that one and become a negative 1. So if we look to multiply, our numerators, we have negative 1 times x minus 7. Because it's subtraction and they're backwards. Okay? And then in the denominator, we're left with a 5. Now you can leave it like that. Some people like to distribute the negative 1. You don't have to, though, but you're more than welcome to. Okay, our next example, another division. So we got to do keep, change, flip. But you can also really do your keep, change, flip, and factoring in the same step if you're okay with that. So we're going to try that. So if we look at the top of the first fraction, what kind of factoring are we going to use? GCF, yes. What is our GCF? A squared. So we're going to have a squared, and then in parentheses, a minus b. So how about the bottom part of that fraction? What kind of factoring is that? Dots, good. So what would that factor into? A minus b times what? A plus b, good. So now remember, we're flipping this next fraction because we're changing it from division to multiplication. So that means my denominator here is actually going to be up on the top. So let's look at the denominator. What kind of factoring is that going to be? GCF. Our GCF would be b squared. So then it's b squared times a plus b. And then the other part, it's just a monomial, so you cannot factor it. It stays as a squared times b cubed. Nothing you can do to it. So now we'll start our canceling. So a minus b and a minus b cancel. What else cancels? A plus b and a plus b. Anything else? Yep. A squared and a squared. So if we write what's left in our numerator, we have b squared over b to the third. Yep, so we subtract our exponents. What do we get? B to the negative 1, which we can't leave it that way, so we got to move it. That comes down in the denominator, and so we get 1 over b. That's our final answer. So then these other ones, they refer to these as complex fractions because if you can look at them, they look pretty complex. You have a fraction over a fraction. But really, what's happening between these two fractions? Dividing. We're doing a fraction divided by a fraction, which we just did some. What do you do with a fraction divided by a fraction? You do keep, change, flip. So, in our first example, I would keep the top fraction, 3/4, stays as 3/4. Changing it to multiply. And I'm flipping my second fraction. So then multiply across your numerators. 3 times 3 gives us 9. Multiply your denominators. 4 times 2 gives us 8. Can we reduce that? Oh, so there's our answer. So our last example, again, we have fraction divided by a fraction. So we're going to do keep, change, flip. So I'm going to keep my first fraction, but I'm also going to factor it at the same time just to try to save us some steps. Bless you. So x squared minus 64, how does that factor? X minus 8, x plus 8. Change it to multiply. What's in our numerator? 16. And then your x minus 8 is in your denominator. So now we can start doing some canceling. So x minus 8 cancels with x minus 8. We can do some reducing too. 16 goes into 32 how many times? 2. So in our numerator, we're left with x plus 8. In our denominator, we're left with a 2. So there's our final answer.